Hello and welcome to your screencast for Chapter 20, Conventional Energy Alternatives. So in this chapter we are going to look at the alternatives and consider what alternatives are out there for renewable clean energy. We're going to consider why we need to seek alternative fuels, and I think we learned a lot of that from the last chapter. We are going to be looking at contributions to the world's energy by conventional alternative fuels. We're going to consider nuclear energy, which we didn't really touch too much on, so we'll look at that in a little bit more detail. We're also going to look at the social debate over nuclear power. Germany, as we know, is using mostly nuclear power. Sweden as well is developing great nuclear power plants. So we're going to take a look at those two areas and see how they are doing with that. We're going to consider bioenergy and hydroelectric power. So those are some of the topics that we will be covering in this chapter. All right, so let's take a look at this picture. This picture is the Barsebäck nuclear power plant in Sweden. I'm going to ask that on your own you please read on pages 553 and 554 the central case study, because as you know our chapters apply to those case studies and use examples all the way through. The case studies would be perfect for you to review for your Apes exam that is coming up, because these are the topics that your free response questions can be taken from. So you might want to just look those over. There's only 24 of them, so that's not too many. And I hope that you are preparing for the exam and reviewing all your notes and outlines that we took this year. Okay, so this slide deals with central case study. I'm going to ask you to read that on your own as well. This shows you where Chernobyl is located, which the case study talks about, so please make sure you look this over. And this is where we're going to start. We're going to talk about alternatives and where we are. So as you know from the last chapter, fossil fuels helped to drive the Industrial Revolution, and it really created an unprecedented material prosperity for the world. The global economy is largely powered by the fossil fuels, with about 80% of our energy coming from oil, coal, and natural gas. These three fuels also generate 2/3 of the world's electricity. They are non-renewable, as we learned, and they're not going to last forever. Already what was easily extractable is gone, and now we're gone, declining. And now we are expending more and more energy and more money trying to extract the coal and the oil through the secondary extractions. Coal, oil, and natural gas also, we know, drives global climate change. That evidence is irrefutable, and it entails other many health impacts and environmental impacts. So most energy experts accept that we will need to shift from fossil fuels to energy sources that are less easily depleted, gentler on our health and on our environment. There is an added benefit to developing these alternatives because they're going to help diversify an economy's mix of energy. And when we do this, it will actually lessen the price of volatility and our dependence on foreign fuel imports. So there's some positives with that. We do have a wide range of alternatives to fossil fuels, and most of what we have are renewable. Most will have less impact on health and the environment, and most will remain unfortunately more expensive than fossil fuels at the start, but that should only be a short term, and as we start to use them more, it should come down. And as our technologies develop and we invest in infrastructure to better transmit power from these new renewable resources, the prices will come down further. And this will help us transition towards these new energy sources. Okay, so taking a look, we've got a couple of graphics here. A represents the world energy production by source. So we can see that oil makes up most of it, coal is the second, and natural gas is the third. And then here is where our bioenergy, nuclear energy, hydropower, and renewables fall into. So they make up right now about a quarter of our energy production. The world electricity generation by source, again, we're looking at coal being the predominant one. Natural gas falls to third place here, where our new alternatives are making up almost a third or a little bit more than a third put all together. So this is a good news for us to see this. Okay, so three of the energy sources that we're going to be considering are the nuclear power, bioenergy, and hydropower, and we're going to refer to these as conventional alternatives through the chapter. So as you can see, we have these three alternatives. Most of the ones that are developed, they're widely used, are the nuclear power, hydroelectric power, and energy from biomass, which we're going to just call bioenergy. They have been well-established energy sources, and as I said, they're going to be called conventional alternatives to our fossil fuels. They exert less environmental impact than fossil fuels. Most of them are considered new, renewable alternatives, but each one involves a unique and complex mix of benefits and, of course, some drawbacks. The nuclear power is commonly considered a non-renewable energy source. Hydropower and bioenergy are generally described as renewable, but the reality is they're much more complicated than just this, so we view them more as an intermediate along a continuum of renewability. As we saw in the pie charts 2 slides ago, and you might want to go back and take a look at them, the amount of energy that they actually provide is only about like 1% in the overall scheme of energy. But when you look globally, it sets a different picture. So fuel wood is another form of bioenergy, and it provides about 10% of the world's energy. Nuclear power provides about 6%, and hydropower provides about 2%. When we look at global contributions to our overall energy supply, they may appear minor, but alternatives to fossil fuels do contribute greatly to our generation of electricity. We see overall that nuclear energy and hydropower together are responsible for about 30% of the world's electricity generation. We also have to consider energy consumption patterns. And when we look at energy consumption patterns in the United States is very similar to those that are used globally because it relies less on fuel wood. It slightly relies more on fossil fuels. Nuclear power, it uses the most from other countries. And we'll be looking at a graph that will show the trends of consumption, and the graph is going to reveal two things. One, it's going to reveal that conventional alternatives play a minor yet substantial role in the overall energy use. And the second thing is that the use of conventional alternatives has been growing more slowly than the use of fossil fuels. So we can go back and we can look at Sweden, and Sweden has shown that a wealthy and advanced economy can replace fossil fuels gradually with alternative sources while continuing to raise the living standards for its citizens. In 1970, Sweden has decided to take the change and has decreased its fossil fuel use from 81% to 38%. Its national energy budget has seen a big cut, and they're seeing that nuclear power, bioenergy, and hydropower are providing Sweden with over 60% of its energy and virtually all of its electricity. Okay, so here's two other graphs to look at. The first one represents energy consumption by source in the U.S. So oil is our biggest energy consumption, then comes natural gas, and then coal. But when we look at this, this is about 3/4. So we rely on at 75% of our energy on the fossil fuels. And then here's our conventional alternatives, and that's only about 1/4 of what we rely on. When we come down here and we look at this graph of energy consumption, fossil fuels, as we know by the pie chart, predominate in the U.S., and we see that the U.S. consumption of fossil fuels has grown faster than that of bioenergy or hydropower or even nuclear power considerably between the years 1970 and 2000. So here's our alternatives. Our bioenergy, our hydropower, and our nuclear power, and that's staying really low, where our oil and our coal and our natural gas are at the highest. So both graphs kind of show that we really rely on those fossil fuels. Okay, so this is going to be the last point we'll make on this screencast. We're going to focus on nuclear power first. And nuclear power has a very conflicted position, and there is a modern debate over the use of this energy. It is free of air pollution, and that means it puts forth as being environmentally friendly because of that. But yet it remains one of our most influential solutions to climate change. But nuclear power's great promise has been clouded by a couple of things, one being nuclear weaponry. We all fear that nuclear weaponry after we dropped the bomb on Hiroshima and we saw what radiation can do, and what happened at Chernobyl and Fukushima, which we'll be talking about later on. There are public safety concerns, and we have spent a lot of money addressing those public safety concerns, and because of that, it has constrained the nuclear power's spread. The little bit of a history about nuclear power: it was first developed commercially in the 1950s. And it experienced most of its growth during the 70s and the 80s. If we look at the United States generates the most electricity from nuclear power, and they generate over 1/4 of the world's production, but yet only 19% of that is used for electricity in the U.S. So we're only looking at a really small amount of what is produced going into electricity. France, on the other hand, leads the list, and they receive 75% of their electricity from nuclear power. Okay, so we're going to end this here, and we will continue with nuclear power in the second screencast. See you on the other side.